12. Assuming these schematics below represent galvanic cells as written, identify the half-cell reactions occurring in each. And then we have Ni solid, which will go into Ni2 plus aqueous, and then Ag plus aqueous goes to Ag solid. Now, in this case, we're dealing with galvanic cells. Remember that galvanic cells are spontaneous cells, or spontaneous reactions, which means that they don't need any additional energy to run these reactions. Now, in this case, they do give us a lovely schematic here. A schematic is basically just another way of writing a balanced equation. But from this schematic, we have to identify what's going on at the half-cell level. So let's just bring out what a schematic generally looks like, which is this right here. Now, it looks very similar to what this is, right? I have a single break. We got a double going on, and then a single, double, and then single. Now, just know that the first part of your schematic is always talking about what's going on at the anode. And the anode in a galvanic cell, a spontaneous cell, means that oxidation is occurring. And remember what oxidation means, right? Leo the Lion says grr. Oxidation says that if you lose electrons, you're going to be oxidized. And that just means that you're becoming more positive. And that's why your starting species is going to go to a more positive species. So in this case, it kind of makes sense, right? Because I have nickel, that was a 0 charge, and then it goes to a more positive charge. So this, the nickel, goes into Ni2+, aqueous. So let's just write that out. We first have the oxidation going on here, in which Ni solid will get turned into Ni2+, aqueous. Which means that if this is the oxidation side, the other side has to be the reduction. And there it is. The second side is always represented as the cathode in galvanic cells, and that's reduction. You could remember this by saying red cat, reduction cathode. And remember, reduction is a gain of electrons, so you're becoming more negative. And that's why the positive charge goes to a lower number. So that's this. Ag plus goes to Ag 0. So that's reduction. So maybe what I'll do is I'll just maybe bring that out a little bit. And then I will say reduction is we have Ag plus aqueous, and that will yield Ag solid. Great. But now they want those half cells. Looks like we have the elements balanced, but the charges aren't balanced. So let's just add those electrons in. Now, nickel, since there was no charge up here, right? There's nothing up here in the upper right-hand corner. That's a 0 charge. And the nickel on the left side, on the right side, is a +2. You always add electrons to the more positive side because electrons are negative. You want to bring the positive down to the more negative. So +2 is more positive than a 0, so I know that I have to add electrons on my product side. How many? Well, it takes 2 to go down to 0. So I'll add 2 electrons here. Do the same for the reduction side. I have a +1, because a plus just means +1. And then I have no charge here, so that's a 0. It makes sense that now the electrons would be on the left side, because +1 is more positive. So I'm going to add electrons here. But how many? Well, it only takes 1 to go down to 0. So I'll only add 1 electron. So what I'm going to do is I'm just going to bring this over here for now. I'm just going to bring this out just so that I have a little bit more room. And then I'm going to say that I have 1 electron. Now, 2 things that we should cover. What happens now if they ask for which one is the oxidant or the reducing agent or the reductant or the oxidizing agent? Just know that if you're talking about agents, not a secret agent, but if you're talking about something that undergoes oxidation, it's the flip word. So a reducing agent will be the one that undergoes oxidation. That's at the anode. And then if you want to know who's undergoing reduction, that's the oxidizing agent. But now there are other ways to determine these agents, just another name for them. Another name for a reducing agent is called the oxidant. And then another name for the oxidizing agent is called the reductant. So just, be careful as to what words they're choosing. So if they're asking for who is the oxidant or who is the reducing agent, it's always going to be one of your starting materials. It's never going to be the ending products. But your oxidant is the one that undergoes oxidation, and that was the nickel solid. So that's cool. And then let's find out who was the reductant. The reductant is the one that undergoes reduction or is the oxidizing agent. And that's the other one, the other starting material. So it's Ag plus, aqueous. Okay, so that's done. We could box that off. Now, let's just see what the final balanced equation is when we put these two, oxidation and reduction, together. Now remember, if we want to add these together, I have to make sure those electrons are balanced. But I have 2 electrons on the right side, and I have 1 electron on the left side. So you always can get them to be the same by multiplication. Seems that I can take this and times it by 2, because 2 times 1 will get me 2 electrons. But you got to be fair. If you're timesing this by 2, you got to times everybody else by 2 as well. So now it turns into 2 electrons plus 2 Ags. So 2 Ag plus aqueous, and then I will have 2 Ag solids. And once I have that new equation, I'm just going to get rid of the old one. And now we add these 2 together. So maybe what I'll do is, just so that everything is together, I'm actually going to bring this down and then pull the whole thing up. There we go. Because now I'm only looking at these 2. So now I'm going to add. So I guess I'll add over here. And now since those electrons are balanced, I can cancel them out. So I have 2 electrons. I got 2 electrons. They go bye-bye. And now I just add up what I got on both sides. So I have 2 Ag plus, that's aqueous, and that's plus the nickel solid. And this will yield the 2 Ag solid, and then plus the nickel 2 plus aqueous, and this is the whole equation. So this is what the final balanced equation would be from that cell schematic. And just know that if we wanted to do those half cell reactions, you would still only use this one and this one with the electrons in there. Okay? All right. I hope this helped. Thanks so much for viewing the video. Give this video a thumbs up if this helped you out, and comment if you want to. Love talking to you guys. And if you wouldn't mind, please press the subscribe button. It just gets the word out there that this channel exists. Tell your friends, tell your classmates about this cool YouTube channel. We try to just help as many students as we can from all over the world. So thanks so much, and I will be talking to you in later lessons. Okay? Have a great day. Bye-bye.